Hello everyone, and welcome back to another Codility exercise. So today we're going to solve the binary gap. So what we're supposed to do is we're just getting a number and we need to convert it, let's say, to a binary representation, and then just return the longest sequence of zeros inside that representation. For example, we have the number 9. So on binary, it looks like this sequence. And as you can see, we have a sequence of 2 zeros together. So we will need to return 2 as the max number of sequence of zeros. Let's have another example right here. It's 529, and the binary representation is this long number. And the max I can see here is 4 zeros together, so we'll need to return 4. So how can we resolve this? We can just, let's start and just showing the solution. I'm not using math here, so we don't care about it. And again, we are getting the number and just want to convert it to binary. So there's just snippet to convert it to a list of numbers, of digits, 0 ones. So it's not only digits, it's all 0 or either 1. So you can see it right here for the number we are now working on. Let's solve the example 529 from the example. And we can see it looks something like this. Let's try to make it even easier. Let's see if I remember. 4 digit 4 digit in digits. I want to convert it into a string and then just join it on. So I think it's something like this. Join. Looks good. Just unlock that. Okay, looks good. So we can use that instead. So you can see how the number looks, and we have a sequence of 4. So we need to return 4 as we're doing right here. So how we are resolving that? First of all, we need to, let's say, we want to do it in an ON time complexity. So that means only one loop for all the elements. So let's start with having a max gap. This is what we'll return in the end. And the current gap. That means that we are going through, that we will be going through each one. So 1, 2, this is our loop, 1 and 2 and 3, and we go through each one of those. And then just decide if we should increase the current gap. And if we reach to, let's call it an ending sequence like 1, or if we have a 0 in the end, so the end will be an ending sequence as well. So if you reach an ending sequence, well, that means that we need to compare the current gap with the max gap we have. So we can have much longer numbers like this. That means that we have a lot of sequences inside it that we want to compare with others. So maybe this one is the winner right here, I can see. But that means that every time we have a sequence, we need to compare it with the max sequence that we counted until here. And if the sequence is higher, that means we need to update the max. Here I call it max gap. So we just need to update the max gap compared to the current gap that we have. So let's see how it works. When we start right here for digits, and if the digit is 1, that means it's not, either it's an end of a sequence or just in the middle. So we can have something like this. That means that this one was ending the sequence, but from here and after until we still have ones, we still don't have a sequence. So we could say it's an ending a sequence, but the sequence was 0. So we don't really care about it. So if the digit is 1, the current gap, and then I will check another question. If the current gap, the sequence left that we are checking, is higher than the max gap, the max sequence that we found till here, if that's true, we're just updating the max gap that we return in the end and zeroing the current gap because we found a 1 in the middle. say we got here, we have 1, 2, 3, 4, we got to 0 to 1, that means this sequence was over. So we are just zeroing the current gap, and so the next zeros will start from scratch. And now, and if we got to a number that is not 1, that means that we are in a sequence. So we need to increase the current gap that we have. If that's a new 0, so the current gap will be 0, and then we just increase it to 1. If we are in the second one, we are doing a current gap plus 1 again, and the current gap will be 2. And same here, 3, 4, and then we get back to 1. And then we compare with the max gap that we have. So the current gap that we have right here is 4. And if 4 is higher than the max gap, and initially the max gap is 0, so the max gap will get updated to the current gap that we found, it's 4. And then we are updating current gap to 0 again, because we need to start a new sequence. We get to 1. And this continues on later. Let's say we got over here and we got 0 again. 0 right here, the current gap is 0, but we're increasing it in 1, and 2, and 3, and we got to the end. And we should probably add a check right here, because we want to make sure that, let's have an example, that if we have something like that, we will not return the max gap because we are not checking that. So let me just share an example here without using digits, because we don't want to guess numbers. And let's say digits equals 1, 0, 0, 1, 0, 0, and 0. And this should return 3 digits. And as you can see, it returns 2. And that's not a good solution. So what we should do, let's check right here. If current gap is higher than max gap, we'll just update that again. And then we should have 3. All right? Yeah, 3. So that's good. And I just clean everything out so you can see what is going on here. And I just start looking for the examples we have. You can see that we have this number 10000, 10001, so we get 4. Let's use 292. Stop getting locked here. You can see we have 2 zeros, so that's fine. All the sequences are 2. Let's use this big number. And we have 3 sequence, so we just have 3 right here, so that's a good solution. That's all. Hope it helped. Hope it helped, and have a great day.